Institute of Aeronautical Engineering, IARE, subject code ACSC07, Computer Organization and Architecture, AAT Concept Scalable Shared Memory Multiprocessors and Architectures, name Maurya Satish, Semester 3, roll number 20951A3329, Computer Science and Information Technology.
Are often used. Symmetric multiprocessors, SMP. Symmetric access to all of main memory from any processor. Also called UMA, Uniform Memory Access. Distributed Shared Memory, DSM. Access time depends on the location of data word in the memory. Also called NUMA, Non-Uniform Memory Access. April 24, 2017. SOAK Architecture. Shared Memory Architectures. A shared memory programming model has a direct representation in hardware. Caches. Increase performance. Demand cache coherence and memory consistency protocols. April 24, 2017. SOAK Architecture. Shared cache architecture. Several processors are connected via a switch with a shared memory. Has been used for a very small number of processors. Is difficult to use for a large number of processors, since the shared cache must deliver an extremely large bandwidth. P1 PM Switch Cache Main Memory April 24, 2017. SOAK Architecture. Bus shared memory. The interconnect is a shared bus between the processor's local caches and the memory. Has been used up to 20 to 30 processors. Scaling is limited due to the bandwidth limitations of the shared bus. P1 PM Cache Bus Main Memory April 24, 2017. SOAK Architecture. Dance Hall Architecture. Scalable point-to-point network placed between caches and memory modules that together form the main memory. Due to the size of the interconnection network, the memory can be very far from the processors. P1 PM Cache Interconnection Network Memory April 24, 2017. SOAK Architecture. Distributed memory. No symmetric approach. The local memory is much closer than the rest of the global memory. Structure works very well with scaling. Important in the design to use the local memory efficiently. P1 PM Cache Memory Interconnection Network April 24, 2017. SOAK Architecture. ARM's Cortex-A9 3-axis buses on the Cortex-A9. FPU/Neon. Cortex-A9 CPU. Instruction cache. Data cache. PTMIF. 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 Generalized Interrupt Control and Distribution. Snoop Control Unit, SCU. Accelerator Coherence Port. AXI-3 Slave. HW accelerators. 64-bit non-cached. AXI-3 Masters. ACP AXI-3 Slave. Cache-to-cache transfers. Snoop. filtering. Timers. Advanced Bus Interface Unit. Primary AMBA 364-bit interface. Optional second IF with address filtering. L2 Cache Controller, PL310. ACP AXI3 Master. ACP AXI3 Master. 3 AXI buses on the Cortex A9. ACP port provides coherent access to L1 and L2 caches through the Snoop control unit. 2 AXI masters off of the L2 cache provide 8 GB per second at 500 MHz access to the main SOAP bus. April 24, 2017. SOAP architecture. Tyler GX architecture. 4x4, 6x6, 8x8, 10x10 chips. 3 instructions per cycle per core. 32 MB on chip cache. 750 GOPS, 32-bit operations. 200 terabits per second on chip interconnect bandwidth. 500 gigabits per second memory bandwidth. 1 GHz operating frequency. 10 watts to 55 watts power consumption. 5 mesh networks, 32-bit, dimension order routing, 1 cycle traversal. QDN, request dynamic network, 64-bit, memory requests. RDN, response dynamic network, 112-bit, memory responses. TDN, tile dynamic network, 128-bit, cache-to-cache communication. UDN, user dynamic network, 32-bit, under SW control. IDN, IO dynamic network, 32-bit, for non-memory I/O. April 24, 2017. SOAP architecture, shared memory programming. SOAP architecture lecture 3. April 24, 2017. Shared memory programming. C. Axel Jens and Ingo Sander. Process and history P1. A process executes a sequence of statements. Each statement consists of one or more atomic, indivisible, actions which transform one state into another, state transition. Process state is formed of values of variables at a point in time. The process history is a trace of one execution, a sequence of atomic operations. Example: P1, A1, A2, M, S0, S1, S2, SM. April 24, 2017. SOAP architecture. Atomic operations indivisible sequence of state transitions. Fine-grained atomic operations. Machine instructions, read, write, test and set, read, modify, write, swap, etc. Atomicity is guaranteed by hardware. Coarse-grained atomic actions. A sequence of fine-grained atomic actions. Should not be interrupted. Internal state transitions are not visible outside. April 24, 2017. SOAP architecture. Concurrent execution. The concurrent execution of multiple processes can be viewed as the interleaving of their sequences of atomic actions. A history is a trace of one execution, i.e., an interleaving of atomic actions of processes. Example: individual histories. P1, S0, S1. P2, P0, P1. Interleaved execution history. Trace 1, S0, P0, S1, P1. Trace 2, S0, S.
Thank you for giving an opportunity to give an ITT Tech Talk. Happy learning.